Rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
Hello students, welcome to S. Chand Academy, the official YouTube channel of S. Chand Publishing. The book here is Mathematics for IIT-JEE Main and Advanced by ML Khanna sir, and I am Subuh Nadeem presenting you the videos of some of the questions of this chapter which we are going to study and some of the concepts of the chapter. So which chapter is this? Let us see. This is chapter number 29. The chapter name is Tangents, Normals and Simple Applications of the Derivatives. So it is about tangents and normals. So if we talk about a curve y is equal to f of x, then there is a point x comma y on that curve where we may have to find the equation of the tangent. So how will we find the equation of the tangent? First we need to know the slope of the tangent. So slope of the tangent is actually m, which is dy by dx. So this will be dy by dx. This is the application of derivative in tangents. After you get to know dy by dx, you can write it as y minus y is equal to dy by dx into x minus x. So this is how you can write the equation of the tangent, and this is the slope of the tangent. Now if you are asked to find the normal to this tangent or the curve at the point x comma y, then what will be the equation of the normal? That would be y minus y is equal to minus dx by dy, because we know that the normal and the tangent, their slopes are inversely proportional and negative of each other. So this will be x minus x like this. So this is the equation of the normal. This is the normal, this is the tangent. And what you have to keep in mind is that this capital Y, capital X are any point on the line which you are taking. So this capital X comma capital Y is any point on this line which you are taking, and X comma Y is the point on the curve which you are differentiating. Next important thing which we have to know here is basically about the intersection of two curves. So if we talk about the intersection of two curves, so it is about the intersection of their tangents. So if we take two curve, this one and this one is y is equal to fx, another one is y is equal to gx. These two curves are there and they are intersecting at a point P, which is x1 comma y1. Now it is asked to find the angle between these two curves at x1 comma y1. So you will find the tangent to this curve at x1 comma y1 and tangent to this curve at x1 comma y1, and the angle between them is supposed theta. So you have to find theta. How will you find theta? So what you will do here is you will take the slope of this tangent, which will be dy by dx at x1 comma y1. And can you tell me what is y here? So y for this curve is gx. So this is actually g dash x1. And if you talk about the slope of this tangent, this is actually f dash of x1. So this is how you get the slope of these two different tangents. Now the angle between them is theta. So tan theta is equal to m1 minus m2 upon 1 plus m1 into m2, and you take mod of this. So this is the angle between two lines as we studied in coordinate geometry. Now another angle will be obviously 180 degree minus theta, which will be obtuse if this is acute. So in that case, tan 180 degree minus theta would be negative of tan theta, which will be minus of mod of m1 minus m2 by 1 plus m1 m2. Now here a special condition can arise. Suppose it is said that these two curves are orthogonal curves. So what is the orthogonal curve? Orthogonal curves are two curves which intersect each other perpendicularly. That means the tangent is actually perpendicular to each other. So this is a tangent and this is a tangent and they are perpendicular to each other. Such curves are called orthogonal curves. So if they are orthogonal, then that means the angle between them is 90 degree, which will give you m1 m2 is equal to minus 1. What was m1? G dash of x1. What was m2? F dash of x1 is equal to minus 1. And x1 y1 is the point of intersection of these two curves. So this is what you have to understand here. One more thing is there before we will start the questions. Another thing is, if you have to find the orthogonal curve, family of orthogonal curves. So if there is a equation given y is equal to fx, then first of all let us differentiate it and find y dash, which is f dash of x. And then when we take the orthogonal curve in the equation, we will replace y dash by minus 1 by y dash. So in that case, we will get the family of orthogonal curves. For example, x square plus y square is equal to a square is a circle with center A, center origin and radius A. Now you have to find the family of orthogonal curves which are actually perpendicular to all the curves which is given here, where A is the parameter. So what you will do here is, you will differentiate it. When you will differentiate, you will get 2x plus 2y dy by dx is equal to 0. Now what you do next is, you take dy by dx as minus 1 by y dash. So you take it as 2x plus 2y minus dx by dy, like this. This is equal to 0. In the next step, you can solve this equation, differential equation. How will you do that? You can take this 2 common and it will vanish, and it will become dx by x is equal to dy by y, and integrate both the sides. You will get log of x is equal to log of y plus constant, which can be written as log of x by y is equal to constant, which means x by y is equal to constant k, which is e to the power c. So we are getting x is equal to ky. Now this equation is the equation of a straight line which is passing through the origin. Now if it is passing through the origin, you can understand over here that if this is the y-axis, this is the x-axis, so any line which is passing through the origin is always perpendicular to all such circles. So this is a way to find the orthogonal curves family. Now we will see few questions which will involve tangents, normals, equation of tangents, normals, their slopes, and we will also see orthogonal curves, angle between the curves. So before that, we have seen all this theory part. Now let us see questions. This is the first question which says tangent to the parabola y square equal to 4ax in the form y equal to mx plus a by m, where m is the slope of tangent. Prove that two perpendicular tangents to a parabola meet on the directrix. So what we have to do here is basically, we have to see that this is a parabola and this is the tangent to the parabola. Now if you take 2 points on the parabola, suppose one point is x1 comma y1, another point is x2 comma y2, and draw the tangents at these ends. So what will happen? The slope of the tangent 2y y dash is equal to 4a after differentiating this equation. So y dash is equal to 2a upon y. This implies that y dash is equal to 2a upon y1, or y dash is equal to 2a upon y2 for these two different points. This is a point, this is b point. For a point, the tangent will have this slope 2a by y1. For b point, it will have slope 2a by y2. Now the equation will be y is equal to mx plus a by m, as it is given. So you can see that the slope m is equal to 2a by y1 for this one. Similarly, for this one also you can find the slope. So this will become y is equal to 2a by y1 x plus a will cancel, y1 by 2. It will become like this. Now another equation would be y is equal to 2a by y2 x plus y2 by 2. Now if we say that these two are intersecting, so what else is given? That these are perpendicular tangents. So if these are perpendicular tangents, then the product of their slope is actually -1. So we can say that 4a square by y1 y2 is equal to -1, as the tangents are perpendicular tangents here. So y1 y2 can be written as -4a square. So this is y1 y2, which is -4a square. This is an equation which we will use, and we have these two equations also which we will use right now. So we have three equations here. Now if these two equations which are written below, these are intersecting at a point, so what we will say, so I am erasing this portion which we have done already. So this result is with us, which is equation number 1. And after knowing equation number 1, equation number 2 and equation number 3, we have to do further calculations. So what we will do here is, we will say that if these two are intersecting, then 2a by y1 x plus y1 by 2 is equal to 2a by y2 x plus y2 by 2, like this. Now after doing this, we get 4ax plus y1 square into y2 is equal to y1 into 4ax plus y2 square. We can write it like this. Now in the next step, it will become 4ax y2 y1 square y2, but y1 y2 is -4a square. So you can say that it is -4a square into y1. So this is -4a square into y1, and here it is 4ax y1, and y2 square y1 is there. So one y2 will remain, and another y1 y2 will be -4a square. So this will be -4a square. Now when you will do further calculation, what will happen? Let us erase the portions which we have already used. So this condition we have already used, y1 y2 is equal to -4a square. Where have we used it? We have used it here and here. So this relation also we have used. Now we have to find basically x. What is the value of x? That is the intersection of these two tangents. That is what we have to find out. So if you want to find out x, what will you do? You will just solve this given equation which we are having and get the value of x. So let us solve this. So 4a will get cancelled throughout, and you will have y2 minus y1 x like this is equal to this. You can take on the right side, a into y1 minus y2. Now y1 minus y2 will get cancelled from both the sides because y1 is not equal to y2, and you will say that x is equal to, because this is y2 minus y1, this is y1 minus y2, so x is equal to -a. Finally this result comes that these two tangents are intersecting at a point whose x coordinate is -a. It is fixed, it is not varying. So this is our directrix, x is equal to -a of this parabola, which we have to understand here. Now let us come to the next question. Next question says, find the equation of the tangent to the curve at any point x comma y. So let us find the equation of the tangent to this curve at any point x comma y. We will differentiate it. So we will get m x to the power m minus 1 upon a to the power m plus y into m, y to the power m minus 1, b to the power m is equal to 0. From here, and y dash will also be following here by chain rule. Then we have getting cancelled, and y dash is equal to minus x to the power m minus 1 by a to the power m into b to the power m by y to the power m minus 1, like this. So this is the slope of the tangent. Now equation of the tangent to the curve. So that will be y minus y is equal to the slope, which is x to the power m minus 1 b to the power m by a to the power m y to the power m minus 1 with a negative sign x minus x, like this. So this is how we can write the equation of the tangent. When we write the equation of the tangent, we have the next step over here, that we simplify it. So here it will become a to the power m y to the power m minus 1 y minus a to the power m y to the power m is equal to x to the power m minus 1 b to the power m x minus x to the power m b to the power m, like this. Now after doing this, we divide by a to the power m into b to the power m. So the next step would be, when we erase this portion which we have already used, now it is only simplification which we are doing, no more substitution is required. But you have to keep in mind what is the original equation, because it may be used. So we will say that it is y to the power m minus 1 y by b to the power m minus y to the power m by b to the power m is equal to x to the power m minus 1 by a to the power m x minus x to the power m by a to the power m. So this is what we are getting here. Now after getting this, you know that x to the power m plus a to the power m plus y to the power m by b to the power m is equal to 1. So when you see this, what will happen? This was a minus sign, right? So we skipped a minus sign. This is minus. So this will become plus. And this is again minus. This will become plus. Right? We skipped a minus sign here. This is a minus sign. So we have to take minus and this will become plus. And then we have x to the power m by a to the power m plus y to the power m by b to the power m. This we take on the right hand side. It will be equal to 1. So we will say that we are having x to the power m minus 1 by a to the power m x plus y to the power m minus 1 by b to the power m y is equal to 1. So this is the final result which we can say is we are having, and we can compare this result with any curve of this form. If you take, suppose it is an ellipse x square by a square plus y square by b square equal to 1, that is m is equal to 2 for ellipse. If you take m is equal to 2 for ellipse, then what will happen? Then in that situation, this will become x by a square plus y by b square is equal to 1, which is the equation of the tangent to the ellipse. So this is a general situation here which we are getting. In ellipse, we were having a particular situation. Next question comes here. This question says, determine the constant c such that the straight line joining the points 0, 3 and 5, minus 2 is tangent to this curve. So this curve is y is equal to c upon x plus 1, and there is a tangent to this curve. So when you take the tangent to this curve, it is passing through 2 points 0, 3 and 5, minus 2, like this. Now we say that suppose it is tangent at x, y. So first of all, let us find its slope y dash. That will be minus c by x plus 1 whole square. That will be the slope at x comma y. Now that will be equal to the slope of this line, which is 3 plus 2 by 5 minus 0. That will become 1. So we can say that minus c is equal to x plus 1 whole square. So what we have done, we have first differentiated this y to get the slope of the tangent at y, and then we have the slope by 2-point form, and that is actually y1 minus y2 by x1 minus x2. So you will get, this is 0 minus 5, as we are getting 3 plus 2, 0 minus 5. So this will be minus 1. Okay, so calculation we have to take care of. So this will become plus c. So it is plus c is equal to x plus 1 whole square. This is one equation. Another equation is that these 3 points are collinear. So we can say that y plus 2 upon x minus 5 is equal to the slope of the line, and the slope of the line is, as we have already calculated it, minus 1. So this is minus 1. So we get y plus 2 is equal to minus x plus 5, or we can say that x plus y is equal to 3. This is another equation. This is the second equation we are getting, and we have the calculation fine with this. There is no issue. And then we have another equation, y is equal to c by x plus 1, which we can write as y into x plus 1 is equal to c. Now let us solve it in the minimum number of steps to get the constant c. So what we can do here is, we can take x plus 1 from here and substitute here. So we will get c is equal to x plus 1 is equal to c by y. So it will become c square by y square, right? It will become c square by y square right here. And then we get y square is equal to c. So there is relation between y and c, and there is relation between x and c also, as we have here. So from these two places we can now substitute here, and x we can write as root over c minus 1, and y as root over c is equal to 3, like this. From here c is root over c is y, and from here root over c is x plus 1, so x is root c minus 1. Now here we get 2 root c is equal to 4, which means root c is equal to 2, which means c is equal to 4. So this is the value of c, which is equal to 4, which will satisfy this condition. So I hope this question is clear to you, students. Now let us move on to the next question. Next question is about find the equations of tangents drawn to the curve y square minus 2x cube minus 4y plus 8 equal to 0 from the point 1 comma 2. So if we talk about this question here, we have to find equations of tangents. More than one tangents may be possible drawn to this curve from the point 1 comma 2. So this point is 1 comma 2 here, and the curve may be something like this, which is y square minus 2x cube minus 4y plus 8 equal to 0. Now if we want to find the equation of the tangent, this is the tangent over here. So we take a point r here, where this is the point of contact, and we take this as x comma y. Now we find the slope. How do we find the slope? We will differentiate 2y dash minus 8x square minus 4y dash. It will be 6x square. It won't be 8x square. It will be 6x square. Okay. Minus 4y dash is equal to 0, which will give you y dash is equal to 6x square upon 4 minus 4 plus 2y, or you can say 3x square upon y minus 2. So this is the slope of the tangent. Now this is passing through 1 comma 2. So if we write the equation, then we can say that y minus 2 upon x minus 1 is equal to, this is the slope of this line, and this is equal to this 3x square by y minus 2. And let us cross multiply. So this will become y minus 2 whole square is equal to 3x square into x minus 1. Now our purpose is to solve this and this equation and get the value of x comma y. So how do we do that? So from here we can take x cube, of course, and substitute there, and we can also take y square here. So better to take y square because this will on expansion become y square minus 4y plus 4 is equal to 3x cube minus 3x square. So we can write y square minus 4y as 2x cube minus 8. So let us take it as 2x cube minus 8 here. So this will become 2x cube minus 8 plus 4 is there is equal to 3x cube minus 3x square. Now this will give you x cube. So you will get, I am erasing this portion which we have already calculated, and we have now found the relation of x from where we can solve and get the value of x. So just see the calculation part now. So the calculation part says that 3x cube minus 2x cube, which will be x cube, and minus 3x square is there, and then we have minus 4 which will go there and it will become plus 4 is equal to 0. Now which value of x will satisfy it? If we take x is equal to 1, then it won't satisfy. If we take x is equal to minus 1, it will satisfy, because this will become minus 1 and this will become minus 3 minus 4 plus 4 equal to 0. So x plus 1 is a factor. So we can write it as x square, which will give you x cube, and you want minus 3x square, so plus x square and minus 4x. So minus 4x square plus x square is minus 3x square, and then you have minus 4x and you take plus 4x plus 4 equal to 0 like this. So you get x plus 1 into x minus 2 whole square is equal to 0. So you get the value of x as minus 1 and 2. So these are the two values of x, minus 1 and 2. So there will be 2 points of contact. One will be R, one will be Q. This R is actually having x coordinate minus 1 and this Q is having x coordinate 2. Now the y coordinate, which is important, we can find out. So if you put in this situation or in another equation also, in any one equation. So I am putting in this equation, let us suppose. So in this equation, if you put x is equal to minus 1, so what will happen? This will become 3 and this will become minus 2, minus 6. So under root of 6 plus 2. So you will get under root of 6 plus 2 like this y coordinate here. As you can cross check, if you put x is equal to minus 1, minus 2 and this is minus 6, but it won't be minus 6 because it is a perfect square. So there is an error here, because if you take x is equal to minus 1, this term will become minus 6. So this cannot be possible. So you can't take this point. Another point is x is equal to 2. If you take x is equal to 2 here, it will become 4, 3, 12 and under root of 12 is possible, which will give you 2 root 3. 2 root 3 plus 2 is the point. And you can find the equation of the tangent after getting the 2 points, or you can write here the xy value and find it. So let us come to the next question now. The important part was basically to find the value of x, the point of contact. So the next question we have, out of the 4 curves given below, choose the curve which intersects the parabola y square equal to 4ax orthogonally. So if we take y square is equal to 4ax as the curve and then we differentiate it, so we get 2y y dash is equal to 4a, which means y dash is equal to 2a upon y. Now we replace y dash by minus 1 by y dash. So minus 1 by y dash will be 2a upon y. Now what is minus 1 by y dash? Minus dx by dy it will be, is equal to 2a upon y. So we have dy by y integral is equal to minus 1 by 2a dx integral. Now this will become log of y is equal to minus x by 2a plus constant, which will become y is equal to e to the power minus x by 2a into a constant, suppose capital A. So we can say out of all the family of this curve which is matching with the given option is option number B, where a capital A is equal to 1. So e to the power minus x by 2a is there. So this is the orthogonal curve. Now let us come to the next question. The next question says the tangent of the curve, this one is parallel to the line, this one at the point. So here the question is quite straightforward. The question says here that the tangent of the curve, this one, so y dash is equal to 4x minus 1 is the slope of the tangent, and it is parallel to the line y is equal to 3x plus 9. So the slope will be equal to 3, as the slope is 3 of this line. Now if you get this, you get 4x is equal to 4, which means x is equal to 1. Now after getting x is equal to 1, you can get the value of y. Y is 2 into 1 minus 1 plus 1, which will be 2. So the point is 1 comma 2 here. This is the point D. Let us come to the next question. Next question says the angle of intersection of the curve y is equal to x square and 6y is equal to 7 minus x square at 1 comma 1 is. So actually the question is something else which will come in the next slide. So actual question is this one. The angle of intersection of the curves y is equal to x square, 6y is equal to 7 minus x cube at 1 comma 1 is. So if we solve this question, what we will have, we differentiate it, we will get y dash is equal to 2x upon 1, that is 2x, the derivative. And if we differentiate this one, so this will be 1 by 6 into 0 minus 3x square. So this will become minus x square by 2. Now these are the slope of the tangent to this curve and slope of the tangent to this curve. What is their point of intersection? That is also important, because you have to find the angle of intersection at the point of intersection, which is 1 comma 1, and 1 comma 1 satisfies this equation also and this equation also. So it is fine. So you can find the slope here as 2 and slope here as minus half, because you are putting x is equal to 1 here and you are putting x is equal to 1 here also. So this is actually f dash of x and this is actually g dash of x. Now at x is equal to 1 you are finding it. Now if you want to find the angle between them, tan theta, so that will be equal to, as we know, m1 minus m2 by 1 plus m1 into m2. So this will become 2 plus half upon 1 minus 1, which will become undefined. So m1 m2 is coming out to be minus 1 actually. So if m1 m2 is coming out to be minus 1, that means the lines are perpendicular to each other, which means the angle between them is pi by 2 at the point of intersection. So that is all for today's session, students. Thank you and have a good day.